This is your brain, the brain of a modern Homo sapien. Within it, you have a frontal lobe, a parietal lobe, a temporal lobe, an occipital lobe, a cerebellum, and the brainstem. But our brain didn't just happen to look like this. It was the work of millions of years of evolution since our most ancient ancestors. Many of us are familiar with evolution as the change in heritable traits of biological populations over generations. This includes our brains. To start us off, let's discuss brain size, because in this case, size matters. That is, in evolutionary terms. John Hawks, a professor of anthropology, says, across nearly 7 million years, the human brain has tripled in size, with most of this growth occurring in the past 2 million years. But while this seems like a long time, it's a fairly rapid change in Earth's history, and while our skulls and brains have grown, it is our brain mass in relation to our body mass as well as the increase in size over time that matters. This is called encephalization. Since brains decompose after death, it's tricky to determine brain changes over time. However, by measuring the insides of ancient skulls, information has been gathered about the volume of ancient brains and some details about the relative sizes of major cerebral areas. But it isn't until early Homo species that we start to see a significant increase in cranial capacity, approximately a 20% increase over Australopithecines. More significantly is the approximate 50% increase in brain size of Homo erectus and the earlier Homo species. In order to make these discoveries, we need endocasts. Endocasts form when minerals replace brain matter inside the cranium during the fossilization process. These endocasts allow paleoanthropologists to study the cortical folds of the brain and compare it to modern humans. The brains of early hominins are symmetrical, but as Homo emerged, we see the lateralization of the brain, meaning it becomes asymmetrical, giving us a left and right brain. In general, the left hemisphere is dominant in language, processing what you hear and handling most of the duties of speaking. It's also in charge of carrying out logic and more exact math. The right hemisphere is mainly in charge of spatial abilities and face recognition. It performs some math, but only in rough estimations. The brain's right side also helps us to comprehend visual imagery. Based on endocasts, researchers determined that 3 areas of the brain began to change in Homo. The limbic system, which processes motivation, emotion, and social communication, the cerebellum, which handles learned motor activities, and the cerebral cortex, which is responsible for sensory experiences. So why did the brain evolve? One explanation involves 3 different variables: group size, complex subsistence patterns, and the nutritional value of meat. In social groups, it is implied that big brains in primates correlate to an ability to remember relationships and hierarchies. For subsistence patterns, it allows them to keep track of territories, which in turn allows them to collect a wider range of food. Lastly, eating meat is a good way to establish and maintain enough energy to power a big brain. Our brains have come a long way since our ancient ancestors, and even now it is thought by some that our brains could still be adapting. It's hard to say for sure, but what we do know is the modern Homo sapien brain is the most complex of its kind.
Created using Powtoon.